Okay, let's finish this problem. So it says, what is the magnitude of the velocity right before the rock strikes the ground? So in the previous problem, we just had a ball being thrown on some horizontal flat surface. And the big difference between this and this question and that one is now we're looking at a person's on a cliff and the ball is thrown from the top of the cliff. So before being said, because it's of symmetry on the parabola, we know that the initial velocity is the same as the final velocity, except the angle, instead of angling upwards, the velocity was downwards. So this one, because the ball started up here and now the object is a lot lower, because it's been falling for a greater amount of time, we know the velocity must have increased in magnitude. So here's our question: what is the magnitude of the velocity right before the rock strikes the ground? So I'm going to write down Vy is equal to V0y plus AT. So Vy is our initial velocity was 30.0 sine 33 degrees, 30.0 meters per second, multiplied by sine 33.0 degrees. So that is our Vy initial. And our acceleration is negative 9.81 meters per second squared. And acceleration is downwards. And our time we found from our previous question was 4.08 seconds. 4.08 seconds. So we multiply that, we have 30 sine 33 minus 9.81 times 4.08. We get a velocity Vy is equal to negative 23.7 meters per second. We know that because there is no acceleration in the x direction, Vx is still 30 cos 33. So 30 cos 33. So Vx is still 25.2 meters per second. And we can draw a triangle from this. The object is traveling to the right, but our final velocity is down. Down and to the right. So we need to find out, okay, this is 23.7, this is 25.2. What is our magnitude and our angle? So our final velocity is going to be 25.2 squared plus 23.7 squared. Square root, you have 34.6 meters per second. And to find the angle, we're going to inverse tan 23.7 divided by 25.2. And we end up with 43.2 degrees below horizontal. Final question is, what distance from the building does the rock travel before hitting the ground? Okay, this one is straightforward. You say dx, horizontal distance. We have V0x, so V0xt plus 1/2 AT squared. Again, because there is no acceleration in the y direction, that just goes away. So you have dx equal to vxt. So it's going to be 25.2 meters per second. Our time was 4.08 seconds. So you get 103 meters.